All right, so we've decided that if we work out the cost of one book by doing 45 divided by 5, we get $9. And so Mrs. Kondo needs 9 times 22 books. How much is that going to cost? 198. All right, can we find a rule connecting the number of books with the number of with the cost? What's the rule? Cost is C equals 9B. Are we happy with that? All right, 0 books, $0. And then what are we doing essentially? Drawing a straight line. That's what we should be noticing. So if we want to go 1, 2, 3, 4, 10 books, and we might want to go up in, I don't know, what do we go up in, 10s? Could go up in 9s. It's easier actually, isn't it? So 10 books, it's going to cost $90. Oops, that would help if I could do this. I went from 9s to 6s. 63, 72, 81, 90. That's what I'm looking for. 10 books, $90. You don't have to plot every single point. You might want to plot a couple. But what you should be noticing, and because I've gone up in 9s, it's really easy because each coordinate is essentially going to, each exact coordinate is actually going to show me the cost of each book. I haven't drawn a straight line through it, only because it doesn't make sense to have a continuous number in terms of number of books. But if you did, I wouldn't get too caught up over it. The point is, it is a straight line. And this is an example of something being in direct proportion. If you increase the number of books, you increase the cost proportionally. And that is by a factor of 9, because you have this scenario, C equals 9b. That is a linear function, right? We're familiar with our linear functions, y equals mx plus c. Well, what does this m value represent? Isn't that just the 9 in this context, which represents the cost per book? It is a rate, and I've talked to you before about gradient representing a rate. In this case, that 9 is the cost per book. So this idea of proportion, as one thing increases, the number increases, or the other way around, as one increases, the other, as one decreases, the other decreases. So if I decrease the number of books I need, I'll decrease the cost as well. That is direct proportion connection here. All right, here's another one. So I've tried to give you a picture for what I was trying to get at here. So we've got this coil. It's connected and connected to some kind of power source, and it is an electromagnet. It's a kind of handmade electromagnet, and it picks up paper clips. There's a picture picking up paper clips. So it's really just trying to give you a bit of a visual to see what this question is about. And the number of paper clips it picks up depends on the number of coils. So the more coils, the more paper clips. And so the connection is based on this. If the electromagnet has 25 coils, it picks up 50 paper clips. If it's got 100 coils, it picks up 200 paper clips. There's a box of 220 paper clips being dropped. Jess, Tomsy, drops the paper clips. We want to pick them up in one hit with an electromagnet. How do we do that? How many coils will it need? Oh, so I've got two answers that are common. I've got 440 and 110. Which one is it? 110. Why? Why is it 110? All right, so the number of coils and the number of is half the number of paper clips. That's the connection between the two. Number of coils is half the number of paper clips. Or we could say it in another way. The number of paper clips is 2 times the number of coils. Well, there's the rule. I've already gone ahead and done it. Sorry. P equals 2 times C. So for every coil we have, we pick up 2 paper clips. We could have looked at this rather than the connection. Probably didn't need to give you both. I gave you both pairs because you could, just to show you that direct proportion relationship, that one is half the other or one is double the other, depending on how you look at it. So it is easier to say the number of paper clips is twice the number of coils. So if I had 1 coil, I could pick up 2 paper clips. So going back down to 1 is helpful. So if I had 1 coil, that picks up 50 divided 25, which is 2 paper clips. So a bit like the maths book question. That constant 2 has a nice link to it because it tells you how many paper clips, well, basically it tells you that the number of paper clips is double the number of coils, essentially, the number of paper clips that's picked up. So if we draw the graph, we could do 100, 200, whatever it is, and then these are going to go up. Number of paper clips. Whoops, I've messed that one up, haven't I? Not really, but it's better to do 50, I think. And 100. And then this. So if I've got 50 coils, I should pick up 100 paper clips. And if I've got 100 coils, I should pick up 200 paper clips. And again, you've got that straight line relationship. And again, technically not drawing the dots, but just because I plotted just a minimal number of points, otherwise it gets quite tedious. But it's that connection there. It's that recognizing that you have a linear relationship that's really important. Yes, Lucy. Sure. So C0. When 2 things are in direct proportion, now there is a difference with what we call partial proportion, but that's not the focus for today. So when 2 things are in direct proportion, we do have this direct linear relationship between them. They will always go through 0, 0. Because if we've got 0 coils, we're not going to pick up 0 paper clips. If Mrs. Kondo hasn't got, there's no cost for the books, or hasn't got any books, then it's not going to cost anything. He's not buying any books, it's not going to cost anything. This is so annoying. Never mind. I don't know what I just did there. When we talk about petrol prices or petrol, it's the cost of petrol versus the number of litres you put in the car. So let's say the cost is $2 per litre, 10 litres, $20, 50 litres, $100, keeping the numbers simple. But that's the connection, right? The cost is equal to 2 times the number of litres. Let's say it's $2 per litre, and there's your rate, $2 per litre. Something else, another example. Shares, yeah, at a fixed price, sure. Cost of your shares in total versus the number of shares purchased. With shares, there's brokerage fees and that such sort, but generally, if we don't include that kind of thing, we're just looking at cost of shares. Yeah, if a share costs $5 and you purchase 50, $250 it's going to cost you. If it costs $5 and you purchase 100 it's going to cost you $500. You're in that, again, it's that direct proportion. Cost of the shares, if the share costs $5, if it states $5 per share.
That would be cheap.
It depends. Yeah, it'd be very cheap if it was something like the Commonwealth Bank shares, which are now close to $100, but used to be $5 back in the day.
You can get shares.
But you can get shares that are cheap with any company that's on the market, pretty much. That's floated into the share market. But yeah, all the banks for sure. Mining companies, you name it. All right. The point is this. What are you noticing about the rule? As one increases, the other increases the same rate. It's a linear rule. And that's probably the most important take out of it. And it's always going to be in the form y equals mx. Not even plus c. That's what we call partial proportion, which is not part of this, what we're doing today. So basically, when we have this relationship, bit of theory now, try to do it in a context where you can get a bit of an understanding of what's going on. If we have that cost per that unit cost, it's a lot easier to calculate these items that are in proportion, in direct proportion to each other. I'm sure you can read all that spiel, but what is important, probably, is that the connection, we use this little symbol, is proportional. That's the symbol there. You may have seen it before. It looks like some fancy, what's in there, that fancy peace symbol or something, I don't know. But that means is proportional to y. It's directly proportional to y. When we say x with that fancy little fish-shaped symbol y, it means x is directly proportional to y. So that is just your two variables.
It looks like an infinity cutoff.
Yeah, infinity cutoff, that's true. And so what we can take from that is that there is some direct linear connection between the two variables. That's what we can take from it. When we see something is proportional to the other, directly proportional, there is a linear connection. And that linear connection has this form. Y equals k times x. And it's that k value that we are often interested in. What might that k value be? Well, in the context of the problem, it represents the gradient of the line. It would be, in the case of the two examples we did previously, it would be the cost per litre of petrol. In the next one, it would be the cost per share. In the book question, it was the cost per book. And so it does relate to a rate usually, but sometimes it's just this constant value that connects the two numbers together. Like the coil question, that constant was 2 because it was twice as many paper clips could be picked up based on the number of coils. So it's the number of, what would we say, number of paper clips per coil. Still a rate there. And so what I want you to be able to do is, in a scenario, be able to come up with this rule yourself. Or, if you're given the rule, be able to answer questions connecting the rule. If I have two people, give me a context of two people, I don't know, who are wearing 4 items of clothing each, then how many items of clothing have I got all together, all that kind of thing. That's a very, very stupid example, but anyway, that's what came off the top of my head. Okay. So here, the other type of thing that you could be given is a comparison or a connection between the two variables. We know in this example that x is proportional to w. So to find an equation that connects them will be dependent on the numbers and how they're connected. Because they're proportional, as soon as you see this, x is proportional to w, we can then write that w is equal to some constant times x. And it's a matter of finding what that k value is. And we can do that by what? How would we find that k value? If we know x is 24 when w is 30, not as logical as the ones we did in context. How would we work out that K value? Very much like how we would work out that A value in that quadratic question from the test. How do we work out the C value in the linear function that when we're trying to solve for C?
Well, you can divide by 5.
We can,
6.
we could. We could go down to 1, couldn't we? What else could we do? What else could we do?
Divide 24 by 4.
Divide 24. There's your 24. And there's your W. Why does that division work? Why does that division work? Yeah, because in that equation, when we are dividing both sides by x to get k on its own, well, that's what we have to do, essentially. So that constant is equal to W divided by x, which is 30 divided by 24, which gives you the unit value that we were talking about before. What is that unit value? The numbers aren't quite so nice this time, so it's harder to see. 1.2, is it? 6 goes into 35 times, 1.25, and into 24 4 times, 1.25. Not that I'm suggesting you have to do that at the top of your head. But then, so that's your constant of proportionality. That tells me that whatever W is, it's 1.25 times x. That's what that means. That's how we determine it, by doing that division. So then putting those numbers then back into the equation, W equals 1.25 times x. There are lots of things that are connected by a directly proportional relationship. Anytime you buy something, assuming there's no multi or bulk discounts, you buy one, you pay a certain amount. You buy 50, you pay 50 times that amount, whatever that is. In your science area, force equals mass times acceleration. So your simple formulas, V equals IR, they are all connected. There is a directly proportional relationship between them. Dependent, actually, that depends. I'll take that back. It does depend on the numbers and depending on what you're connecting, what two variables you're connecting. But in this case, we are connecting W and X by that constant 1.25. All right, see if you can complete. There's 3 minutes. See if we complete those questions. And then your homework tonight, math space, direct proportion. And you haven't had homework for a while, so it'd be really good if you worked on this one tonight. 2 minutes, let's go. 3 minutes we've got still. Complete this.
Well, you should I just need 27 times 2.
So to start with these, you need to make sure, if you know something's in direct proportion to the other, straight away before you do anything else, you can make this assumption. And we've gone through the theory behind why that works, why you've got that linear relationship there. We try to do a few examples in context to get you giving yourself a feel for how that works. So if M is 14, what's N? And if N is 30, what's M? Well, from here, you can see N is 3 times M. So even logically, you can tell me what those figures might be. Because N is 3 times whatever M is. What about this one? Because we know these variables are in direct proportion, what can you tell me about them? N equals K times M. So what's the connection? What's the K value? We've got this, coordinate that will help us. K is 9. And then from there we can fill in the rest. Once we know what K is, we can bring it back to 1, 9. K, we've got 1. If M is 1, N is 9. We can bring it back to 1 even if we want. All right, so how does this work in a context? We've got 1 minute to finish this off. In fact, I think I'll make you have a go at that. Finish that off. And the maths-based task, because otherwise I'm going to be just telling you the answer.